Hello and welcome to Hutsons-Hacks. Previously we looked at deploying a CARET machine learning model in Plumber. Today we're going to be building on that and we're going to create the Docker file for that. So this will be deploying our trained CARET model with Plumber and Docker. So let's get to it. So first of all, we'll just collapse that. Right, so first of all, we're going to set our project structure up similar to this, and I've called it folder of Rocker deployment, but it could be anything really. It could be named whatever you want, my plumber project, whatever. So let's just revisit from the previous session what we did. So I'm going to open the plum stranded R file. That's loading up for me right now. As you can see, it's still loading. Okay, so now we've got this model. And we built it in the previous section. So essentially in that folder there, we've got the trained outputs of our machine learning model. It was the stranded patient model that we dealt with in the first video. If you go back to your stranded plumber data set here, we're going to load in the relevant libraries. So we're going to need plumber, we're going to need YAML, because we're going to set the open API spec of a product called Swagger. So first of all, we're going to read in that model, specify the model info is correct. So it was a bag tree model, tree-based model ensemble that we developed in the first tutorial. And then we went through what these mean. So a GET request in terms of HTML and HTTP. A GET request is getting something from a particular server or web service. And POST requests are posting things back to that web service. So here, this is where it handles the prediction based on the model that we've read in here, model. It'll predict off that model and specify the new data. And it's going to specify that as a data frame because there's going to be multiple items in the request body. So the request body, when we use our web service, in the body of that, there'll be the setup of the stranded patient dataset. So it'll expect the same columns and the same input size. We'll visualize that shortly. And then we went into the setting the layouts in the previous section using a YAML file. And just to remind you, the YAML file essentially sets out what the user interface of the Swagger app looks like. So it says my local hosts, the port that it's going to be available on, 80, remember that because we're going to expose that in Docker shortly. The description of the API, and then it's going to link to the specific paths. So connection status, if you can see that, it's one of our plumber endpoints. Connection status here, it's got to link up to that. And predict, so our predict method is that data frame, post predict, so it's going to be our post method. And essentially it's going to take in all these parameters and these properties here. It's going to look for an object. We're going to pass in JavaScript object notation, JSON. And it's going to use type, number, a title as a stranded patient age. An example would be 52. And these parameters here actually match the values expected in the CARET model: age, care home referral flag, medically safe flag, HCOP flag, needs mental health support flag, previous care in the last 12 months, frail or inactivity limitation, frail full patient history, and frail mobility problems. So essentially that's got everything we need to create the Swagger user interface. If you run this API now, you'll get the Swagger file that appears. as we created in the previous step. So this is our stranded patient prediction tool, and it will give you the connection status. If you try it out and execute that, it's going to give you the curl request. If you're going to use another application to send those requests, you can simply do it that way. The request URL, so you can paste that into your browser and it will show you the connection status. And this is the response body. So as I told you, in the response of the R script, it needs to look in the response body of the request. So this says my connection to my stranded patient API is successful, the date and time, and the username that's accessed that. And then the post method is passing in these predictions as we did before, trying it out through this JSON tag. If you wanted to add multiple items, you'd put brackets there because it expects a list. I'm going to execute that, and it will give me a prediction of what it thinks it is. So it thinks it's not stranded 100% and 0% stranded. So I'm going to talk stranded. I'm talking about patients that got a very long length of stay, and this is normally down to factors like age. So if I bump the age up to 98 and execute that, it's going to change the probabilities. Now you're getting closer to becoming stranded. And if I probably set that they've got mobility problems, that's probably going to tip them over the likelihood of being stranded. So 56% are now becoming stranded. So this is how you can deploy these predictive models out. So not only have I got a class label, but I've also got the predicted probability here. So what I want to do is, this is on my local machine. So when I close my machine down, it's not going to work again. So what I want to do is put it into a Docker container, and essentially you'd want your container also residing on the server, but it'll mean that the API is always persistent, so you can actually utilize it whenever you need. So the next step is just to create another file. This is not what you saw in the previous tutorial, but we need another file in our main directory, and I'm going to add all these files in the root directory. So we're going to load in Plumber again. We're going to just suppress warnings. And instead of clicking that Run API button like we did before, we need to then code in that click. So plumber plum will do the same thing as Run API. So this file essentially just runs the tool for us. So it's linked to the name of the stranded patient Plumber API we've just seen. So we click Run, and that'll run this Plumber app. And we want to expose port 80. And it's very important when using Swagger that you add these two commands. The host IP's got to be on the local host of the Docker container. So that's 0000. If there's a lot of reading behind the actual best IP address, but that's the one that seems to consistently work with all Docker containers. And then you need to indicate that the Swagger, so it expects Swagger, that API that we've just seen, is equal to true. Once you've done that, you can run that script, and it will run that API as we did manually earlier. Right, so we've got all the R files that we need to start. So the next thing we need to do, so let's go back to our file directory. I'm going to save this. The next thing we need to do is create a Docker file. So all this is in the same directory. The archive, it's going to ignore that anyway. That's just some old scripts I was working with. So can you see that the type of the Docker file is just file? So we don't want it saving as a text file. So you want it basically without any file extension, because essentially when we load Docker, it's going to look for a Docker file. So let's edit this I'm going to edit it with Notepad++, but you could do it with normal Notepad or like Visual Studio Code or whatever. I'm going to edit it with Notepad. So we're going to build out the Docker file here. I'll probably zoom in a little bit so we can see what's going off. So because my installation of Plumber is the most current, you could specify the actual version by using the package versioning. But what I'm going to do in my container, I'm going to install all these packages. So to step through this, what we're going to do is use Oz Docker packaging called Rocker. I'm going to use the version that's linked to the right version of Plumber. So in this instance, I know that it's R version 4.0.2. We then run this line, and this performs updates on the Docker container because it's got essentially a Linux kernel. So it'll expect Linux commands, bash commands, so apt get, apt update, apt install. This is kind of a standard update syntax that you run on the server after you've pulled all the R versions through. So when I put this in the GitHub repository, just use this as is. You might want to change the version and the packaging dependent on your specific task at hand. And then we're going to set a maintainer so we know who's built this package, Gary Hutson at Hutsons-Hacks. And then line by line, we're going to run with special shorthand commands. So we're going to run R, normal install package commands. You could do this in one line by just installing your packages as a vector. I think this way though, it just helps you see what we're installing on each line. So we're going to install Plumber. We're going to use Reader because we use Reader to read in the model. We're going to use YAML because that'll set our open API spec of the Swagger file. We're loading CARET because that's what the model was built on. We use iPred because we use some of that functionality in the predictive model. We're going to use Swagger, which is the UI, the Open API that we utilize. And we're going to load in rapid docs as well. This is kind of R's version of Swagger, similar to that. So after we've done all this, we've loaded in the actual base installation of R. We've done updates on the Linux kernel. We've specified the maintainer is. We've installed any additional packages with the run command. What we're going to do then is we're going to essentially do a shorthand to copy everything in this directory here over to our Docker container. So think of a Docker container as a little machine that's isolated off from your actual specific environment. This bit's very important. We're going to expose port 80 because in the previous file we set 80 as the open port to utilize when you're actually going to be accessing this web service. And then our entry point, so we need to specify that it is actually going to be utilizing an R script, and it's going to be using the plum stranded R file that we developed earlier. And this is essentially the run API button that we utilize that we've put into code. Again, just refer back about 5 minutes in the video if you're getting lost there, because it explains what that does. So now we've got all this, we've created our Docker file and it's saved without a file extension. And again, you could take the copy of the one in the GitHub repository that I'm going to load in and just go and do the same kind of editing of that file and add your own dependencies. You can use this as like a base template to start with. So I'm going to close that down now because I know my Docker file's got everything in it that I need. Okay, just let me, Docker file's got everything I need. So now what we're going to have to do is we're going to load up, we're going to install if you've not got it previously installed. I'm on a Windows version. It makes it a bit more difficult to utilize Docker on Windows. But I'm going to load up Docker. But if you need to install it, Docker for Windows. And it will tell you the processes and the steps to install Docker Desktop on Windows. Again, Docker Desktop for Windows. And a couple of things you need to do is enable your hyper-virtualization settings. So you need to make it virtualized. So by saying virtualized, Windows needs to know that you're going to be using a emulator of another operating system. In this instance, this is all built on Linux. So you'll need to enable all those settings and update your Windows components for WSL2, which is the Linux open source virtualization options. And then it'll give you all the relevant details on the Docker Docs website. Once you've downloaded that, your Docker app will look something like this. You can see that I've got a strand of patients, and I do like the names of these containers. These are randomly generated, and you get some really interesting ones. Charming, Leaky, and my image. You can see my image is built down up here. Stranded patient, and I've got a lot of failed attempts that I probably need to do some cleaning up later on. I had a couple of issues with package versioning, etc. to try and make this work. See, that's what it will look like on a Windows machine. So I prefer to work with my Docker containers in Windows PowerShell. I think if you're using Mac, you'd probably use their equivalent command line, and Linux, you'd probably use Bash. So what I'm going to do now is I'm going to open up Windows PowerShell, and I'm going to open it as an administrator. So to make sure that I run this as an administrator, click yes. Okay, let me just bring this over to the relevant window. Okay, I made it nice and large so you can see. So I'm going to teach you a bit of PowerShell commands, pretty similar to what there would be in Bash. So I'm going to change my directory, so cd, C, and I'm going to go to users, Gary H, desktop. Then I'm going to have a look at the dir, so I'm going to look at the directory, so what's on that desktop. Gives you all the list of files and what's going off there. And I've saved a separate file called rocker_deployment, so I need to navigate again to that. So I'm going to use change directory again, rocker deployment R. And then I'm going to have a look at the tree, have a look how it's structured. We've only got a file called archive. If I need to look at so that'll look at all the subdirectories. If you use dir, it will look at everything that's contained in that directory. So you can see that I've got everything that I need now to begin with. So this is where it gets fun, and I've got a few pre-cached ones ready to go. So to build this container, we're going to use docker build. I'm going to specify T to install a new container. We're going to name this image, stranded patient. So that's going to be my image name. And essentially this period here says, in that folder, copy everything over on the build. So essentially, all of this good stuff will get copied over. If I hit return, enter, you'll see that it starts to do some installations. That built really quickly in like 2.9 seconds. You'll find if this is the first time installing this will take probably up to 15 to 20 minutes to get it sorted. So okay, we've built this image now. We can see that if I go to my images, you can see stranded patients there, and it was created less than a minute ago through that command line. And if you want to get rid of any of these, you can just remove them if they're linked to a specific container. You might have problems up here. So to get rid of them, you'd probably have to delete the containers that they relate to first, like this boring bonsai container. Get rid of that, get rid of this. And again, that's just probably just me tidying up something that I probably should have done before I hit record. We've got this one as well. And we've got one that's running. You can see it's running on port 80. Okay, and I'm going to run that again. And that one. Okay, I think we're done. And if I wanted to get rid of those images, then I could just go down and get rid of all these that say none. I'll do that after I finish recording. So the next thing to do, so we've built it now. We've got this image, stranded patient. Next thing to do is actually to set that running. So I'm going to go back into PowerShell. I'm going to CLS, so I'm going to clear all the stuff above. Okay. And just a quick note, if you've never used PowerShell before, you can tweak the settings by right-clicking here, go to Properties, and you can change the font size and the layout and stuff like that, coloration. Okay, so here I'm going to now run this. So I'll break this down. So Docker, so you have to specify Docker each time you want to work with Docker, same with Python, etc. if you're using PowerShell. We're going to run our image. We're going to set the port, so we're going to actually map the ports. So we're saying map the current port 80 to the one in the Docker container, and that's the one that we know is open. And then stranded patient matches the actual container name, so that's got to match what we set up earlier in the build step. If I hit enter, so I have got to I probably got to stop that as well. Docker stop stranded patient. Okay, no such container stranded patient. Okay, I might have to do it in the UI then. Yeah, just stop it. It is running actually. No wonder I can't access it. Let's stop it here. You can see that's now been stopped. So I'm going to run that command again. Okay. So docker run stranded patient. So I'm going to press enter again, and this time we should be more successful. It's firing up. Great stuff. Loading package lattice. Perfect. We've got our web service up and running. So our Plumber API is at this, and actually it's this bit that I need, the docs, which is my Swagger documentation, API, sorry. So I'm going to open Google, and I'm going to copy what I've just copied here. And as you can see, we've got our own web service. It's perfect. So I'm going to try this out, execute. So we've got the curl request that we could utilize. This web service is every time machine's ready and running, this will automatically start running. So it'll be persistent. Obviously, if you had a server bank or an Azure account, you could set this to persist forever, so it's always available. So for like big industries and big organizations, I know big mobile companies like T-Mobile, etc., use Swagger and Docker apps for deployment. And we've essentially just created our own little web service here. This does all the nice visualization complexity for you. And all you need to know is a little bit of R, a little bit of Plumber, how to create a Docker file, and a bit of PowerShell. But I've kind of taken you through the processes and the steps here. And the predict method, so that will get me connection status to say it's connected. I've obviously got a problem with the username because it can't actually get the system username in Docker, and there isn't a user in Docker, so that feels a bit redundant when you deploy it into a Docker container. It was working before. And then the predict method. So now I've got my request body. I know it's all got to be passed as JSON. And again, you can change this to work with JSON file inputs. And you could even just have form inputs that you just change and alter. But I quite like it as JSON because it's a web standard of passing data between. And if you hit schema, you've got the actual schema that underpins it. So what the fields are, what data type they are, what's a more interesting title that might make it more contextualized, and what's an example input that you might pass through to that. So in this instance, it's 50. And that goes on. So then it says care home flag. These will be binary flags of 1 and 0 to set those. And yeah, then you can make your predictions. So let's try it out like we did before. And I'm going to take this and I'm going to copy it. So I'm going to put a comma and I'm going to then wrap this in a list, Python style. Okay. So I'm going to keep that one as is. I'm going to set this to 87. I'm going to say that they're not part of a healthcare for all people ward. If they're a frail patient, if they've got mobility problems, let's say they've got mobility problems. Let's say they've got problems with their activity. Let's say they need mental health support. I'm going to execute that. And now we've got our predictions returned. So essentially what that's doing is going to our R script in the Docker container. It's sourcing this, loading this CARET model that we've previously built. And then that CARET is returning the predictions. And as you can see, we've got that API all set up, ready to go. What I'm going to do on the back of this is I'm going to actually submit you the GitHub code, and that'll be in the YouTube description. If you liked this tutorial, please subscribe, and I hope to put on some more Docker and perhaps not Plumber this time. I might do it from a Python perspective, so using Flask and Docker together. But yeah, keep posted for that, and yeah, see you on the other side.